Yay.
Hello everyone, happy Halloween. Welcome back to the Fastly YouTube channel for an extra spooky edition of our monthly developer live stream. My name is Kalen Blanks and I am part of the developer experience team here at Fastly. So as part of that team, I produce content to help those building the web make use of our compute and delivery services, which hopefully you are aware of by now and have possibly even used before. Over the past 7 months, we've spent a lot of time on this show working on applications that generate HTTP responses at the edge in response to requests for web pages. We've been able to achieve a lot with this, including delivering experiences that update in what feels like real time, such as the waiting room that we built back in February. But the extent of the real-time data that we display here is very basic, and it only works because the client is continuously requesting updates from our service. As users of the dynamic web, our reliance on data that stays up to date in real time has grown significantly, whether that's sharing memes in chat applications like Discord, or expecting reliable and up-to-the-second financial quotes on trading platforms such as Robinhood. Developers are often left on their own when it comes to figuring out how to approach delivering these updates to millions of clients in a scalable and efficient way. In 2022, Fastly announced that it had acquired Fanout, which is a web push platform built on open technology that gives your API real-time superpowers. Now, in 2023, we are pleased to announce that Fastly Fanout is in general availability, meaning all of our developers can take advantage of our one-of-a-kind global network to deliver data as soon as it is available, whether that is via WebSockets or our other supported transport protocols. To show us the power of Fanout and Pushpin, the open source proxy that makes all of this possible, I'm very excited to welcome to the show Katsuyuki Omuro, author of the Fanout client libraries, and now one of the talented engineers that I have the pleasure of working with as part of the developer experience team. Welcome to the show, Kats.
Hi, Kalen. Thank you so much for having me here today.
So I'll
As
pass it on to you. Take it away.
yeah, as Kalen just explained, Fanout is a real-time web data publishing mechanism. As he described, I was the author of some of the libraries that support Fanout on our platform. Actually, as we just learned, Fastly acquired Fanout last year, and I was one of the engineers who joined Fastly through that acquisition. So here I am to describe Fanout to everybody today. So happy to be here to do this. Now, I want us to think about a little bit about an API. So if we can take a look at my terminal window here, I have a terminal window, and I have an application running locally. I'd like to show you what happens when I request this endpoint. Notice that I have one product. Well, could be products, could be users, anything, but I have one product named Alice, and it's 100% complete building it. Now, I can easily create another one by posting. So here's a post. I'm creating one with the name Bob, and I post it there. And now I have one with an ID of 2. I can request details about these. So if I request ID 1, it's going to be Alice. If I request ID 2, it's Bob. And by now, the percent complete is 100. But let's think about what happens if I do Charles. This is going to be 3. And I request information about it right away. Notice this is only 35% complete. If I hit it moments later, the percentness increases until it's fully complete. And this kind of ties back to what Kaylin was saying earlier about we can get updates as long as we keep querying very often. But let's think about how much does that scale? Does that scale very much? If we have something that's being created, you have a lot of requests going through, and every single time you want to know if something is ready or not, we're going to be querying if this is every 10 seconds or every 5 seconds, every 1 second. You have these trade-offs, like if you query too often, you're going to send a lot of traffic over the wire. But if you query less often, like maybe every 10 seconds, then your UI is going to stay stale while you wait. So you have these trade-offs. If you think about the best way to do it, it's actually to have a streaming response. So I want to show you what happens if we can get a streaming response. And the way we do that, we're going to get the same endpoint, but we're going to use an accept header of text event stream. And notice that if I do it this way, I get a streaming response. Notice it ended when it hit 100%. So the first time I hit this had been 60% complete. And as time went on, it went on to 65% complete, 70% complete, and so on until it hit 100%. And this whole time, the response is hanging. Like even right now, the response is still hanging. We've not returned control. Now, the benefit of this should be obvious because you don't have to keep on querying. As the data becomes ready on the server side, it's going to be sent to the client. Now, obviously, that's ideal, right? But how do you implement something like this? What do you think the best way to implement this would be? So today we'd like to think about real time. We'd like to think about what does it mean to be real time and how we can implement something like this. So really quickly, what is real time? What does it mean for an endpoint to be real time? Well, in this case, when we say real time, in this context, we're not talking about like latency. We're not talking about the actual amount of time it takes for a message to propagate. We're actually talking about a connection that comes in from the client and is held. And we can call it near real time because the data, as it becomes ready, it gets propagated to all the clients. And the most important thing is that the visitor does not need to refresh their website. If they're on a website, they don't want to refresh. If you're doing something, you don't want to go check. Instead, you want a push notification or you want some badge to show up on your bell, on your UI or whatever. There's a million uses for this. You chats, you can have notifications, you can have progress bars. Like this example here would be a progress bar. You can have breaking news, or you can have stock ticker, you can have location sharing, there's collaboration. For example, you can have a documents app where multiple people are editing the same document at the same time. And obviously you can use this for gaming as well. But APIs with real time. What do you think about APIs with real time? Do we need APIs with real time? Well, we actually believe that the future is in APIs, right? Many web apps these days are actually just UIs built on top of APIs. So if your app is going to need real time, then as APIs start taking over the world, then your API is going to need real time as well. Now, if it's imagine that it's an app that you're building. If you're building an app from scratch or you're building a new project, you can use a third-party library. There's libraries, products out there like Firebase or Pusher. These things are really great. If you're building an app, then your backend makes a call to these services, and then your client app can use their library to get these messages, and you can update your UI in real time. That's great. But for an API, that wouldn't really be the right choice, or it would be an odd choice because as an API author, you want to be able to expose a standard HTTP API. Like you don't want your consumers to You don't want to require a consumer of your API to have a certain particular client library to use or to adhere to the data structures that are designed by a third party. No, you want to be able to design your API surface. So in order for you to be able to design the routes, the data structures, and the authentication, et cetera, you need to be in full control of the API. And that is what Fanout enables you to do. So, sorry, I'm talking for a long time here. Kaylin, do you have any questions so far?
I have no questions. I'm just curious if you could let us know about the protocol that makes this all work.
Yes. So I want to talk about this code, the terminal program or the terminal window I showed you earlier. What would it take to build a real-time API like this? Something that would stream only when you ask for it with a certain header. Well, foremost, the difficult part is that your server has to hold the connection to the client. So in my case, whatever my web server here is that's running on port 7999, it is still holding this response open. This is the part that's very difficult to scale, and it's also the part that's difficult to get to work with CDNs. Now, if you're building a new system from scratch, you might be able to choose like a language with an event-driven structure. Maybe you can use Node.js, or you can use some framework that might be out there that uses an event-driven structure. But what if you want to just add real-time to your existing system? You already have a system and you want to be able to add real-time to it, or something like that. Then in that case, you have to resort to something like, okay, we're going to have an existing system, and then we're going to be building real-time version of the API on top of that, because most of the time, all these existing systems, if you're using something like PHP or Python with Django, or you're using, even with Node.js, if you're using something like Express, it's generally really difficult to expand that with real-time. So you're going to have, maybe you'll use a route to say if any APIs that are using these routes are going to go to this real-time system, and everything else is going to use the existing system. Parts of the app are going to have to be rewritten, or you might have to duplicate the code between frameworks, or sometimes even between languages. And that causes this weird segmentation, and maintenance is really, really hard. And so today I'm here to show you that Fanout lets you escape all of these. And to do this, we actually use a technology that we call grip. So let me show you a little bit about grip. So here's grip. You see my screen or my, yeah, okay, cool. So grip is a proxy server that lets you build real-time push APIs. And the way this works is that the grip proxy holds all of your long-lived connections with the clients. The grip proxy communicates with your API server, which is your backend, your origin, and it uses standard HTTP messages for that. So in other words, your API server is free to speak normal HTTP messages that start and end, and you do not have to worry about holding all your connections, because the grip proxy does that for you. And the grip proxy that does this is the program that's called pushpin. And that is also what Fastly Fanout runs. I would like to go to the source code of the application that I showed you earlier and show you how easy it is to do this. So you can see here that this program I'm running, you'll see it says node.index.js. So you'll see that this is the actual program that's running. So the very first thing I showed you is /products. /products will get you a list of all the products that it knows about right now. I'm going to bring my terminal window back up and curl that. And you can see right now that there's Alice, Bob, Charles, and Dorothy all at 100%. So that's just an endpoint that gets you all the items. You can create a new product with the products endpoint with the post I showed earlier. And then here is the one that gets you the details. Now, usually, see, if you do request it with text event stream, you're going to go through this path. And if you don't request it with that, then it's just going to go through the normal path here where it takes the product and just gives you a JSON object. But the part that's interesting is when we are proxied through grep. We're proxied through grep, and we are including text event stream in the accepts header. So if our accepts header includes text event stream, then we are going to go this path. Now, if you are behind a pushpin proxy, if you're behind Fastly Fanout, those are grep proxies. So the grep rules say that they will insert a header called grep sig, and this will let you know that you're behind a grep proxy. And also in production, you should also check the value, make sure you can trust the proxy. Now here, what I'm doing is I'm saying that I'm giving these instructions to grep. I'm saying, please hold this as a stream, and then use the channel with the product ID. And that's actually all. When you request this, if you remember the first time I called it, I'm going to bring up the terminal window again. Let's say I am requesting product number 5. Sorry, that's not a good one. Let's if I request product number 3 for some reason, then notice it gets the current data, prefixes it with the data, word data here. It displays it, and then that's all. But because the grep hold header is there, the grep proxy, which I'm hitting, is able to know that it wants to hold, oh, sorry, not this one. This one. The grep proxy knows that it wants to hold this open. So this is kind of exciting. You can see that earlier I told you something's running on port 7999, but if you look at this, you'll see it's running on port 3000. And that's the part where pushpin comes in. Pushpin is a proxy server that's running on 7999, but my main node program is running on 3000. So that is where the grep proxy comes in. Now, the other part of this is, how do we do the real-time updates? And remember here, we held the channel with the product ID. And later on, I have a special database that every time something changes in the database will call on with progress. The event name is called progress. So I just have here, it receives the entry, the database entry. So whenever there's a progress bar change, then I'm building a payload here. Now this payload format is described in the grep specification, but basically it's a list of items. So in this case, I'm saying I want an item going over the channel product -1 or 2 or whatever. And then here's the data over HTTP stream. We support a couple of formats, but the main one that you're going to be using is HTTP stream. So in this case, we're going to say we're going to add the message here, this content, the data colon, whatever, with the new updated entry over the HTTP stream on this channel. And we post it to this grep publishing endpoint, 127.0.0.1, 5561. This is the publish endpoint that is used by a pushpin when it's run locally. So simply by calling this endpoint, you are able to get these updates to show up here. So that is how you send data over grep.
That's really cool. I'm wondering, that publish endpoint that you have obviously there, it's running on localhost. How would this work if you were using Fastly's network?
Yeah, so if you are using Fastly's network, there's going to be a couple things that are different. First, you are going to be running your origin server somewhere, and you will be fronting it with a compute application. The compute application has to be written with a certain command that will enable it for fanout. So the compute application will run, and then you're able to examine the request that comes in, and then you can say, I want this to be handled by fanout. And so when you do that, you can say, I want it to pass through fanout and go to this origin. And then you would hit your origin code. You'll receive the same grip signature header, and then you can still use the same grip hold and grip channel headers to get Fastly Fanout to hold the response. However, when you are actually publishing, this payload looks identical. However, it's this part that's going to be a little bit different. I don't have a live example here today, but I can tell you that what it's going to be is it's going to be just like a standard Fastly API call. The endpoint is going to be https://api.fastly.net. I'm sorry. Yeah, it's the usual api.fastly.com web endpoint, and it's going to be /service/your service ID and then /publish, I believe. So it is just a standard API call, and you can call it with a normal Fastly API token. So you can find the information about that on the developer hub. It's just a normal API call that you would do.
Are there any differences between the capabilities that are available when you're running this locally versus when it's running on the Fastly network?
Differences in capability, yes, the global network is going to reach your global customers way faster because it's everywhere. But in terms of its functionality, no, they are not, because we are just running pushpin at the global level on Fastly.
So you would be able to take the exact same code, just update the URL, for example, with a configuration variable, and it would just work.
That is correct. Yes, you would be able to modify your source and do it that way. Yeah.
That's amazing. Well,
yes. In fact, okay.
No, sorry. Go ahead.
Oh, no. So in fact, we actually have one more thing to show you with this demo, and that is that we actually have, for JavaScript, we have a library called servgrip. And let me check that code out and show you. Okay. So for the JavaScript version, for JavaScript and running Express, we actually have a utility library called servgrip, and this serves as a Express middleware, where you can specify your grip configuration. Like, for example, in this case, the publishing URL is here. If this was for Fastly, you would have a different configuration here where you get to specify your Fastly endpoint, your Fastly service, and there would also be things like an encryption key to help you decode the servgrip. The grip signature and so on. And you can read more about those on the developer hub. But by doing this, and by using app.use on this middleware, when this endpoint, for example, is called, earlier we were checking for the grip sig header, but this middleware gives you access to, for example, request.grip.is proxied, and this will let you know if you are behind a proxy or if you are behind a grip proxy, and it'll even do the validation for you on the signature to make sure you're behind a grip proxy that you can trust. Also, the response grip has some utility functions to say you can start instruct instead of having to write the headers out by hand. You can call these functions, and then when the middleware sees that you're done, it will insert the right headers into the response for you. Another thing it does is the publishing is simple. You have a publisher object that you can call, and instead of having to write out that large JSON object, you can say simply, I want to publish this data on this channel, and it'll do exactly the same thing. So let's run this one. And if we go back to see if I can find the right window here. Yeah, so if I can it's going to start over because I don't have any products right now. But if I make a new object right now, go back to my notes here. I can say, I can go like this, and then, you know, it's the same thing because we're using the utility library instead. So if you're using JavaScript or any of the languages we have the utility libraries for, then you'll have an even easier time using grep to expand your application.
So you mentioned that if you could use this library in multiple languages. To clarify, does that mean that you can use this without even using Computer Edge?
You can, well, okay, that depends on what you mean. You always have to have a compute application at the edge that will enable fanout for your request. So in the case, your outermost application, your edgemost application is going to always require compute so that you can enable fanout. All the connections are held by the edge, but your origin application can be written in any language. It can even be written in languages like PHP or Python, or you can have an IIS server running ASP if you want. It really doesn't matter because all you need to be able to do is issue these headers and issue the post to the publisher endpoint. Now, one thing I want to show you, because this was if you recall, this was an event stream. Event streams are actually easy to use in a browser because a browser has something called an event source. Event sources are, if I can find it, here we are. Okay, an event source is a special object in the browser that you can create, and you set it up with a URL. So notice this is actually going to product/ID. And when you do that, every time you get that data message pair, like we saw here, every time you see data and then this message, it'll call this callback function for you and send the data as e.data. So you could parse that data, and then you can do something with that. And so right now I'm going to show you what that looks like in a browser. So this is not the page I want to be on. This is the page I want to be on. So this UI is very simple. It just it's asking for a name, and I'm going to enter, like, I don't know, Eric, and I submit that. And notice that we're seeing the same results as we would have in the command prompt, or sorry, in the terminal window. You can see I have a Windows background there. Now, I can do that for any number of things. And the way this works, if you open developer tools, yeah, that's right. Unfortunately, in Safari, it doesn't let you see the contents of an event source. It only lets you see that you got an event source. So let me go to Chrome. Okay, so in Chrome, you can see that, I don't know, what's after F, G. Did I do G? George. Okay, so if I submit this, then I can go to here, and you can see that the event source messages are coming in, and you can see them in the browser right away. And this is very good in a browser because you can see. Can I see the source code here or not? I can. Okay, so you can see here that the event source happened every time I submit the form. Every time I submit the form, it will make a post on the products thing. It'll find what the ID is. It'll create a new row in this table, and then it'll hook up the event source to it. And as it gets updates, it'll update the progress bar. So that's the progress bar demo using Fanout. Or this is actually using Pushpin locally.
Am I right in thinking that if you didn't do this, you would be continuously polling with loads of HTTP requests to basically check the progress of the creation?
Right. Yes, you would be doing that. And potentially, depending on what you're doing. If you're doing a progress bar where it's just you're creating an object in the back end of some server and you only do that once in a while, that's not a big problem maybe. But imagine if you're in a chat room and you're always wanting to keep the chat room in sync and you're always listening to the stream of messages by polling any updates. That can quickly pile up to a lot of messages, especially the more people you get in a room, the number of connections, the number of polls will increase exponentially. So in order to avoid that, I have one more quick demo, and that's the chat demo. Let me show you that. So with the chat demo, I'm going to Control-C out of the progress bar demo, and I'm going to open the chat demo. Now, this is the chat demo, and let me show you what it looks like when I run it. I need to use a certain version of Node. So again, I'm running on port 3000. And I have pushpin configured on port 3000. So when I run this, I'm going to immediately go to the HTML for this so that I can show you how it looks or how it works. So I'm going to just go here, and you'll see that I have this crude UI where it asks for a username and a chat room ID. So I'm going to say that I'm Bob, and then I'm going to join the room foo, and I join it. Okay. Now I'm going to have another window over here where I need to. Okay. So this guy over here is going to be, I don't know. This one will be Alice, and they will also join foo. Now, if Bob says hello, and I send the message, it shows up immediately in the other one saying that we have a message from Bob. And then over here we can say, yo, Bob, right? And it shows up in the other one. Now this is using Fanout. So there's only one request live right now in each browser window. You don't have constant polling. You just have one event stream that's just waiting for updates. Every time someone posts an update, how's it going? Then this window receives it just because it's connected to the same stream. Let me show you quickly how that works. So I'm going to give myself a little room here. Okay, so here I'm using that same grip library, so the serve grip thing here to simplify my code. But over here, let me show you that in the API endpoints, I have a stream endpoint, which uses the same grip as I showed before, make sure we're proxied. We're going to look at the room ID, which is the query parameter. So we're going to be in like /API/chat stream !room ID equal foo. And once you're there, it's going to subscribe that connection. It's going to hold it as a stream. It's going to hold it open as a stream and subscribe that connection to room-foo. So in the case of my two browser windows, both of these are connected to foo, room-foo. And I end the connection there, but that's fine because now I've handed off to pushpin. Pushpin's going to be holding the connections. And then whenever there's a chat message, someone submits a chat message, all we do is we deserialize the body, we add a timestamp, and we create a payload called chat message with the username, the message, the timestamp, and we publish it to that room. And that is quite literally all we're doing. You can have as many windows as you want open to this. Like I can easily do this, have another one that says I can join the same room using Chrome. It's a different browser, but I can say Bob, Alice, and Charles is here joining foo. And then we can say hi all, and that will show up in everybody else's window as well. And this is all because they're all listening to the same window. Pushpin keeps track of all of that.
You said that you could have as many windows as you want. If this were running on Fastly Fanout rather than your local machine, how many are we talking? Are we talking hundreds, thousands, millions? Where's the limit?
Well, we don't actually have like limit numbers that we can say, but we do know that we can safely go into the millions. Like we don't have a published, we don't have like a public number that we say, we don't have like a guarantee, but we do know that we can go, we've tested millions and things have been fine. Also, when you're using Fanout, Fastly Fanout, keep in mind that the messages are going through the nearest location from the visitor. So if you are in the UK and I'm in Japan, then if we're in the same chat room, the messages that are coming out from the origin are actually reaching us through our nearest Fanout or our nearest Fastly location. So that makes it even better.
Incredible.
Yeah. So let me show you real quick the HTML to do this. The HTML to do this is, as you would probably expect, it's very simple. The most important thing here is we have the event source that connects to API/chat stream with the room ID. And then as we receive messages from here, we have one for the title and we have one for the chat message. And as we receive those messages, we just dispatch them through the publisher and all the visitors get that right away. All the visitors get it because all the visitors will receive this message, and each client will process that message through this function, and individually they will all process them. So like if I come here and I set the chat room title from foo and I change it to bar, then you'll see everybody's window has updated right away. And this
So
would
this is
even work. Go
I'm
ahead.
just curious. This is working without any kind of client-side JavaScript library. This is purely available in the standard web SDK.
Yes, yes. This is just a stream. So in fact, I can go here to get it with a stream. I can go curl, curl with accept text event stream, and then I can go to HTTP localhost 7999 and go to chat stream !room ID equal foo. Is that what I do wrong? Oh, if I'm using a question mark in the URL, I have to quote it. Otherwise, it thinks that I'm using a wildcard for the question mark. So I need to, there we go. Okay, what happened this time? Yes, it's API/chat stream.
Of course,
Right,
that's what you've decided to name the endpoint, right?
Right, yeah. This is right. So if I come over here and I type another message like, I'm going to move this up a little bit. Right, if I come here and I type a message like, what's for dinner? You'll see that it shows up here as well, right? Because obviously, because we're listening to the same stream. If you set the title to Baz, then you're going to see that here as well. So you can see all the messages going over the wire because these are all just standard APIs. No client library needed. It's just event source is the only thing that's happening. Oh, one little note is that if you use event source, the browser will automatically set the event stream accept header for you. So that's why we didn't have to do anything like that ourselves, but keep that in mind. If you use new event source, that's going to happen.
That makes sense. And so far, we've only looked at this in the context of the browser, but of course, you have all of these messages coming into your terminal as well. So I'm assuming you could use this to also build native apps, perhaps mobile apps, using the same API for all of your clients?
Yes, certainly. This is, yes, we use browser just because that's very native to HTTP as our examples here, but any application that uses HTTP and has the ability to just stream the response, as long as you can get it to somehow use the HTTP streaming, trigger it somehow, you can use a header like this if you want, or you can make certain routes always stream, or you can just unconditionally stream on certain routes, whatever you want. But yeah, you can use it for web apps or native apps.
That's great.
Cool.
I believe that's all you have, right? Apart from some ending comments.
Yes. Well, because I get asked this a lot, I'm gonna do this real quick. A lot of people ask me about WebSockets and what happens. Is there a way to use WebSockets with Fano? And actually, there is. With WebSockets is a bidirectional communication thing. So notice that in our current example here, we had to use an event source for all the messages that are coming from the server to the client. But for all the messages that the client sends, for example, if you enter a new username and we send that to the server, we're calling a /API/title or /API/chat message. These are post endpoints that are also on the server. But with WebSockets, the single socket is bidirectional. So at Fanout, we built something called WebSocket over HTTP, which is a feature of Pushpin. It's also, well, it's sort of a sub-spec of grep, where we allow you to basically process WebSockets in a certain form. And I'm going to check this out. I'm not going to go into too much detail because you can read about it in our developer hub, and you can also read about it in the Pushpin documentation. However, if you look at the code, actually, I should probably just show the diff because it's very, very simple. But here's what the diff looks like. Okay. Instead of an event source, we're going to use a new WebSocket. And instead of chat stream, we're going to use chat WS. It's still called message, the thing that comes in that you parse. And notice that the function here is identical, right? This is all the same. Instead of getting an event source with message, you're going to get a chat. You're going to get a WebSocket. The other thing is when you send messages to the WebSocket, instead of using these other APIs, you're going to just use WebSocket.send to send the same payload. Same here too. So using a WebSocket will allow you to use one messaging channel instead of having to make more than one for every little thing you do. The server side is also pretty simple. We do have some helper utilities to do WebSockets because the messages are a little bit complicated, but instead of having a chat stream, you'd have a WebSocket, and then you'd have some similar things that we did here. Instead of having the request.grep, you'll have a thing called WebSocket and the WebSocket context. And for this, you can check to make sure it exists. And then you can receive the WebSocket message from the context. You can parse it out. And so over here, in the past one, we had API/title as a post endpoint, but in here, you're going to check the contents of the message and process it. Notices it's exactly the same except for the indentation. And instead of publishing an HTTP message, you publish a WebSocket message. So it's a little bit different, but the idea is very similar. The only difference is that you're sending all messages through that one WebSocket instead of using a separate post endpoint for everything. And actually, that's the only difference here. But we're actually natively sending. So if I run this version of the code, let's run this version of the code real quick and then show you what the developer tools will say. So over here, if I send a message that says, whatever, notice that this thing here, sorry, is it chat WS is a, sorry for the small, let's do this. See how it says the type is a socket for this one? And if I look at the details, you can see that it's a WebSocket connection. So we're actually dealing with real WebSockets here. You're sending real WebSockets, you're receiving real WebSockets data. So this is, unfortunately, I don't have the time to go into super detail on this one, but this is all documented in the developer hub as well. And it's all about converting the WebSockets into HTTP for us to handle in our applications.
That's really interesting.
Yeah. Before I end, let me quickly show you a couple more slides. This is not very long. So, right. So the rest of this. So I just showed you that using grep, you get real-time APIs with the freedom to design your own API. You can use any programming language with any framework. There's no need to separate the real-time and non-real-time code paths. Like I showed you, you can say that with this request header or with this request parameter, you're going to be able to just add real-time by adding these headers. So you can add real-time to your existing API stack. The grep sequence diagram, I think you get it already, but basically it's the client makes a request, the grep proxy sees it, it requests it, it forwards it to the API server. The API server will send back the response with or without grep instructions. If the grep instructions are not there, it just forwards the grep proxy. It's just a very simple proxy response. It does nothing with it. But if the grep instructions are there, then potentially the grep proxy will hold it open as a HTTP stream or as a WebSocket. Oh, and it can contain initial payload. But the important thing here is that after this happens, the grep proxy and the API server are disconnected. The connection no longer needs to survive beyond this point because the grep proxy holds the connection to the client. The client's just there waiting for additional data, and then at a later time, the API server can make another push using an HTTP post to the grep proxy, and then the grep proxy can send additional payload or more than one if it wants. This is compatible with any API management. These are just HTTP requests, so they work with your existing authentication, logging, etc. You can just add this to your existing API stack. Yeah, so you can, this is a rehash. You can use the grep spec to implement the functionality in your API, real-time API functionality in your API. You can use any programming language. You don't have to separate the code. And you can selectively enable real-time for any request for any reason, and you can just add it to your existing API stack. If you want to get started with a grep proxy, which I'm sure you do, please go to pushpin.org, listed here. We have here the reference implementation of grep. It's open source. It's published by Fastly. It's available for Linux and Mac OS. It has an Apache 2.0 license, so you can add it to any project that you want. You can use it for development or for production. You can run it on-prem, or you can run it in a VM or whatever you want to do with it. And of course, we have Fastly Fanout. That is our managed version of Pushpin, where we run it on Fastly's global network. It runs everywhere, or I should say it runs around the world. And the cool thing about this is the connections from the clients are held at the edge. So it makes very efficient use of the resource. If I'm in Japan and Kaylin's in the UK, then these connections are held respectively from the nearest edge node that we're connected to. And here's some references. Go ahead and screenshot this if you feel like it contains the references material for the grep itself. That's the protocol that we talked about. I actually feel like I didn't say what grep stood for here. grep stands for Generic Real-Time Intermediary Protocol. And like I was saying, it's sort of a way that Fanout decided we're going to say, instead of you coding directly for Fanout, please code for grep. And any vendor that wants to implement grep is free to do that. Pushpin is our open source grep proxy. It's our reference implementation, and it is also the software that's running on our edge nodes as well. So please check this out. And we also have an article about Fanout on our developer hub. So that's it from me today. Thank you very much.
Thank you so much, Katz. That's been absolutely fascinating to hear about. I think it's worth echoing as well. The thing that you said about grip and building for grip rather than fan out is really important. It really aligns with what we're trying to do at Fastly with WebAssembly, where we want your computer applications to be able to run anywhere that WebAssembly is supported. So following the same thing here, I think Fanout has been a fantastic acquisition for Fastly, and I'm really excited to see what our customers do with it, not just building new applications, but just enhancing the capabilities of their existing ones by adding a few lines of code. It's really, really powerful. So again, thank you, Katz. Thank you to our wonderful viewers for joining us today. We really appreciate having you here. We'll be back again next month for another really fascinating developer live stream. And yeah, definitely check out fastly.com/sign up, make an account, try Pushpin on your local machine, and then deploy a service to Fastly using it on our fantastic Edge Cloud network. Thank you again, and enjoy your Halloween. Bye-bye.
Hey, bye.